Hello, it's very nice to see all of you here, and I'm really glad that I was invited to this interesting conference. I would like to add something to the technological innovations, even though this one that I will present, it's not, let's say, so new or so new in means of technological advances. I'm representing the National Institute of Mental Health, located nearby, only a few minutes from Prague. And actually, with our colleagues, we are working on some projects that are aimed on cognitive training in elderly population. Of course, due to cognitive decline that was mentioned here several times during today, it is clear that we need also some non-pharmacological approaches towards it, which is usually represented by social communication skills and various programs, including cognitive training methods. And currently, research is showing that cognitive training using digital technologies can be actually quite effective, but the best way is to combine some various practices. For example, the drill practice approach, which means that you are repeating some tasks, but one is based with strategy-based approaches. So it means that the elderly is using some strategies how to compensate for the skills that are already lost and cannot be completely covered again. However, it was shown that new technologies such as virtual reality could actually bring us this easy way how to simulate various activities of daily living that could be actually trained in simulated environments. And in this way, we increase the ecological validity of the methods that we are preparing. However, immersive virtual reality, using, for example, virtual glasses, could be problematic in some way, even though we are mostly using this technology. I will not present it here today because especially during COVID pandemic, we found out that, of course, it will be very problematic to work in this elderly population that was a bit isolated. We couldn't attend them, and we also couldn't work in group settings. So that's why we aimed for some remote training methods at that time that will be available also from home or senior homes and so on. So our aim is actually to create some technology that would cover the approaches I was mentioning about before. So it's strategy-based approach mostly that will be ecologically valid, which means they are trying to build some complex tasks, even though it can be very simple on the computer, but they should include some social skills. They should also include some tasks that are similar to everyday tasks that the senior can be training. And of course, we want to target the cognitive domains that are affected yearly in the cognitive decline, and also track the progress and give the feedback to the senior as positive as possible. So we actually, some time ago, built a basic prototype that was including SQL database, but I will not bore you with some technical details, but I wanted to show you that we actually have a combination of desktop application that is installed on any device, computer device, and web interface that actually allows the senior to look at his results at any time point, even from different devices. The desktop application actually includes several mini games that are, however, organized in some way. And the way it's organized is a so-called training day. So we built in the prototype 20 training days that actually allow the senior to enter some new place that they are visiting or moving to in this game. And they are meeting new neighbors, so they have to know some stuff about them. They have to communicate with them and remember some information, even that it's very simplified. Then we ask them, using some mini quizzes, if they remember this information, and this can be repeated also in next days. In the meantime, they are also visiting various locations in the house. which actually include various mini games which they are playing, targeting memory, attention, and other cognitive skills. Of course, we were interested how the seniors liked it in the beginning, so we did a feasibility study with 35 seniors, mostly females, but you could see there is actually almost 50-50. And they are aged from 60s to 78. Importantly, we wanted to see, in this case, green colors, which means that the technology is applicable, easy to use and intuitive, which we found out. But of course, we have also some, even though only limited negative answers, so we have to get this feedback and use it in later stage of the technology development. We also wanted to know how easy it is for them to install the game, to download it and stuff like that. So you can see that there are definitely some small issues here that have to be dealt with in some specific cases. And then we asked them actually about individual mini games, how they perceive them, and you can see that they were mostly amused by the mini games, which is of course important for the training itself, because they have to be motivated to come back and use it again. And of course, it's important to have good game control, which is also shown here, because without that, they will be just frustrated. And finally, the difficulty level of individual games have to be set the way that the senior can deal with that, but still it's demanding enough. And what we wanted to see here is mostly this gray color, which means that it's adequately challenging. But because we worked with mostly healthy seniors, so it wasn't MCI or other cognitive decline, which will be more than subjective. We, of course, have to be prepared also for worse answers. So it's possible that we will do a study with patients with mild cognitive impairment to see if the difficulty level that was set in the beginning of the games will be actually applicable also in these seniors. So this was only just a shortcut about the study, because we are still working on this technology. So this feasibility study just showed us that it's actually working quite well, but we need to do some changes, definitely. Nevertheless, we are using now this as a training protocol in repeated measures with healthy and mild cognitive impaired seniors. And we are looking for the results of this study, and we will actually adjust the technology afterwards based on the feedback that we already got to improve it for the future studies. And we will like to test, of course, effectivity of the training to see if it can be effective to let's say not improve the cognition, but to slow the cognitive decline, to keep the seniors as healthy aging seniors as long as possible. So that's our target for future studies. And we are preparing some clinical studies for that. So that's all from me, and this is a study supported by this project. And this is our small team that is currently working on this project. Thank you very much.
Thank you. We'll keep the questions for the end. And I would like to invite our next speaker, Marek Budenzel, Associate Professor in the Technical University in Kosice. I hope okay. Faculty of Electrical Engineering and Informatics, Center of Applied Cybernetics. He was speaking about cloud system for AI in rehabilitation. How did it start with Rehab Piano?
Thank you very much. So okay, maybe use this. So without much ado, I will go on. I'm from Technical University in Košice, and it's special in many regards, but for me, this is also kind of special that we have here two buildings separated in time and space. One is our university main building, and the other one is the former CIA headquarters in Langley. Okay, so we focus on, well, what I would like to talk about here is adaptive rehabilitation. And we know all the reasons, it was mentioned here many times, why it is important and so on. So I will just focus on the adaptivity aspect. So the idea is that we want to create a feedback loop between the machine that's aiding the rehabilitation and the patient. So in a process of optimization, the machine looks and searches for the most suitable stimuli for the person. And we started and we are continuing a development of a sensing device, which the first prototype we can see here. We call it Reha Piano because somehow it resembles a piano. And so it's measuring the forces of the fingers. And we developed this prototype into further versions. We try to improve the ergonomy. It was partially financed by a project and so on. So we hired a professional designer to help us to achieve some like better looking and also like more usable device. And we 3D printed the prototypes using HP machine from a high quality plastic that's we can use it for construction purposes. So here's a second prototype used for optimization. We optimized the prototype with close cooperation with the medical staff of the University of Louis Pasteur in Košice, with the rehabilitation ward. And we somehow have this as the present, we call it an advanced prototype because it's still not a production version, which looks like that. I'm there with the scared expression in my face, like what is it doing? And this device, it's not active as I mentioned, it has only sensors. And we developed several computer games. When the patient plays the games, the device is measuring different aspects of the patient's forces of the fingers. For example, we started analyzing the tremor, which is usually measured by accelerometers, but when you compress your muscles, contract your muscles, it's a different type of tremor, which may give us a different information regarding the diagnosis and the possible treatment, future treatment. So it also has vibrational stimulation for visually impaired people, and also if older people after stroke operated the device, it may be much easier to provide the stimuli to the fingers using vibration than providing visual stimuli on a screen. And here are a few screenshots from the games. So what this game is doing is just, it's very simple. It stimulates the person to squeeze the hand as hard as possible, and we can measure the force, of course, how hard the person squeezes, but also we can measure the differences between individual fingers, between left and right hand, and so on. And also during the squeezing, we can focus on the tremor that's generated when the muscle gets tired and appears as a specific form of tremor. Another one is measuring the speed of reaction. So there are small like green balls falling from the top, and the person is supposed to respond to the falling ball by compressing the finger, which corresponds to the falling ball. And again, we can measure the speed of the reaction. We can compare the symmetry between the two hands, and so on. And another game is also sort of derived from the examination of Parkinson patients, where they are supposed to do this movement repeatedly. And so the person is compressing the hand repeatedly, and we are measuring the changes in the frequency and the force of the compressions over time. But, we measure a lot of data, and what is for me the most important is not the device actually, because it's just one of many possible devices that can exist, that can be implemented. But what we did and what I value the most is the cloud system that forms sort of a core for plugging in different devices and plugging in different modules for analysis of the data. The system, we have the diagram here, but essentially it has an interface for a medical professional, so the medical professional can review the results of various patients and propose the activities the patients can, should do, and the patients can be remote at home or at the hospital doing the activities the doctor prescribed. So it somehow makes the life of the doctor easier because he doesn't need to attend to every single patient that much. He can cover more patients, and a less qualified personnel can supervise the activities, or it can be even unsupervised. And so another interface is for the patient. It's all web-based, so the patient can access the games via a web interface. And the third thing is the cloud storage of the data, because using the common protocol, we simply upload the data to the cloud where they are analyzed using different methods. Some of the methods included also artificial intelligence, like for example, artificial neural networks that diagnosed if the person has Parkinsonian tremor or not. We have tested it on a relatively small group of healthy subjects and Parkinsonian patients. And now we are preparing a larger trial using a sample of healthy individuals and a sample of, we hope to achieve at least 60 patients over the period of 1 year with the device. So that's from me. Thank you very much.
Thank you very much, and we'll make the questions later, all of you. I would like to invite Ruby Rebecca Muller. She is accompanied by her associate Florian Melzer. She's the project manager at CAROS, Consilium Saxony. She represents Health Lab for Value, a Central European program. And she will be speaking about unlocking innovation, Health Labs for Value, collaborative approach.
Thank you very much. I'm here to represent this project, Health Labs for Value. Originally, I was here with a colleague of mine, Emily Hickman, who would present our digital pilot to you. Unfortunately, she wasn't able to come, so I will try my best to do her part the best I can. Okay, Health Labs for Value is an Interreg-funded project which started in March 2023 and will go on for 3 years. We are 6 countries that take part in this project, with the lead partner being the Hungarian Central Trans-Danubian Regional Innovation Agency. Every partner or every country has a healthcare provider and a knowledge partner. Instead of Austria, because Austria is actually our key knowledge partner with the Center of Social Innovation. We are focusing on the following problems. Yeah, we have an aging population, as we know, after those 2 days of great presentations here. And with this aging population comes an increase of chronic diseases. This means for the healthcare system that there's just an overload on patients in the future, especially in Central Europe, and increased needs and demands that lead to less sustainability. We have rising data on inappropriate care or limited and wasted resources regarding staff and materials and funds. And looking at research and development activities, there's actually an imbalance of technology and information transfer in Central Europe, especially between Western and Eastern European countries. So one way, or our way of fighting those problems is simply cooperation between the countries. So we need to boost this cooperation along the value-based healthcare chain. The project goals are supporting the transfer of digital solutions, especially through living labs and the Open Innovation 2.0 principles. There we are bringing together members of the so-called Quadruple Helix, which are healthcare organizations, companies, policymakers, and especially patients and their families. And jointly, we try to improve the introduction of patient-oriented digital solutions. And especially here, we are taking patients into the center of this whole process because they are the end users of our healthcare systems. And they will profit from the development and implementation processes the most. Within the project, we are trying to fulfill those four outputs. First of all, in 5 of the 6 countries that are participating in this project, there will be implemented 5 territorial living labs, or we call them health labs, and they all will have their own action plans to ensure an ongoing process in those living labs. In every living lab, we will have a digital pilot, and that will be launched, or an existing pilot will be already upscaled. And jointly, we will try to develop a transnational strategy to establish a network and ensure an ongoing cooperation even after the project ends. And yeah, here comes our pilot, the German part, which was originally Emily Hickman's part. We are promoting or supporting the development of an app called ActiveTap. It's developed by DORA GmbH. It's short for Digital Orthopedics Application. And this is a startup that evolved from the Technical University Dresden Research Group Digital Health. It will be the first holistic health application for hip tap surgeries that's independent of other systems and can be used by any service provider, because the currently existing apps or programs are only specifically from some clinics or insurances, and we want to just broaden that access for patients. The problem that it's based on that we have in Germany over 200,000 implant surgeries per year, with a rising expected number of 33% until 2040. At the same time, the inpatient stay after surgery will decrease about 50% in the next years. This is a trend that's called ultra-fast track surgeries. What that means is that the patients won't have that much support from professional healthcare providers after the surgery. And so they need to take greater responsibility on their own rehabilitation progresses. And so we need to there's an increased need for information and guidance on their side during the healing process at home. But that comes with problems because there might be difficulties getting enough access to sufficient information. For example, by controversial information they get from different healthcare providers, or, I mean, everyone's talking to their families and friends and the World Wide Web to find guidance, and that might just be controversial and misleading. There might be a lack of time on the healthcare systems providers, or just simple nervousness at the patients, because, I mean, 40 to 80% of the knowledge we gain during a consultation, we forget those immediately. So we have the risk of misconduct or misbehavior on the side of the patient, and that puts the risk of the puts the success of the surgery into risk. It can lead to a reduced quality of life, and in 1 out of 10 cases, it can even lead to necessary follow-up interventions, which already costs the German healthcare system over 100 million euro per year just on avoidable follow-up surgeries. What the app does specifically to fight that, it's accompanying patients for 3 months before and after the surgery, and has 4 features In this little video, you will get some little insights on the current status of the app. I'm sorry, it's in German. We don't have an English version yet. The two main features are knowledge and training. So before and after the surgery, there are targeted and evidence-based information and compact knowledge modules. Those contents include, for example, how to deal with excitement before a surgery, or how to avoid falling in the wrong way to not dislocate your new hip joint, or how to just deal with everyday situations, like how are you supposed to put on a sock if you're not allowed to bend over 90 degrees, and how just to deal with that. In the training that you see at that moment, actually, there are little videos that show patients or introduce patients to little exercise sessions to train necessary muscle groups. They are developed by experienced physiotherapists and will be available in different levels of difficulty. We have two side features. Those are diary and reminder. The diary function includes continuous monitoring and recording of progression, a general well-being, pain intensity, and daily physical exercises. This will especially be important for physicians to adjust the basic treatment plan for every patient, for example, to adjust medication or training exercises. And the personal reminders are about when's my next appointment, when do I have to take which medication, on which dose, or the simple, you didn't do your exercises today, so get started. Currently, we are in a conceptual and technological development phase. By the end of 2024, we hope to finish the testing and development phase by using the quadruple helix and TAP patients. So we already had some workshops where the current state of the app was tested, just to get really good feedback and use it right away within the development phases. At the beginning of 2025, we hope to release the app. And for the future, Dora will try to implement this app as a health application for the German market, just to make it funded by insurances and to allow more patients to access it, hopefully for free. Yeah, if you're more interested in more information, you're welcome to reach out to us. We're here until the end of the day, and thank you for listening. Thanks.
Thank you very much, and we move forward. I would like to invite Hanan Namaruti, a PhD student, Faculty of Information Technology Department of Electrical Engineering and Information System, the University of Pannonia. She will be speaking about the effect of color on the well-being of older adults, a comparative study.
Ladies and gentlemen, thank you for having me here in this great opportunity. And I will start with the first, at the beginning of the first session, I like that quote, leaving no one behind. And because of that, there is a lot of studies related to virtual reality approach consider elderly people. So there is some guidelines and tips we should follow while choosing these virtual reality games or entertainment program. Today I will present the effect of color on the well-being of elderly people, and this is a comparative study. I will start by the introduction, then the method, showing some results, and the conclusion. With the rapid increase of using virtual reality by different ages of users and in different sectors such as healthcare, which was we saw some of applications and things in these sessions. Education, well-being, and entertainment. Researchers focus on improving well-being and the quality of life of elder adults. So this seeks us to find, to improving the well-being and the quality of life of elderly adults. So we will investigate the relationship between the effects of color and virtual reality by doing some reviews, and now we will present some most cited articles. We choose 4 articles to understand how color affect that, how elderly people respond and engagement while using virtual reality. The results. First, let's show some guidelines related to those 4 articles. They give us advice to use red-black correlation on white background. So let's see this. The text on red and black on the white background. This is better than this one. And imagine this on 3D environment or 3D space. So the advice is to use those 2 colors on white background better than other colors. The other tips is to use large size and center placement to ensure that the target elements such as buttons or important information is large and positioned in the centers. That's it draw attention and makes it easier to notice. Let's see this, which is bigger, and you can see it's in center. It's better than this one. So this study, I should mention that by 2 Chinese researchers, and it's most recent study done, and they give us this advice. The other one is high contrasting color. So we should take attention to use the high contrasting color. See the black and white, or let's say the orange and the blue is better than blue and the green. We should also pay attention to shades and light and reflection. So to make the aims for clear and consistent color without shading or glare. Let's see this, which is without any shade or reflection, and this is 3D elements, is better than both of these, which is of one of shade and other of with reflections. So how these guidelines affect the well-being? So contrasting colors could help seniors to finish their tasks. Imagine this on virtual reality game or things or tips you want to show them, and you want them to finish the tasks. If you use these colors, is better than others. And lighting play an important role in the vision of old people and help them in movement. I want to say about this point that on that experiment there is a door at the end of a room and want the elderly people to move in that virtual reality game to the door. And they spot a light on that door, and if the light was like affect their perception on some ways, their movement was slower. And positive emotion can be derived from choosing high contrast color in rooms where seniors feel loved, safe, and comfortable. Another study showed that there are a significant difference between warm color and cool color in terms of achieving tasks and performance of old people. The performance here measured using the number of wrong tasks and time consuming of performing the tasks. Conclusion. Virtual reality developers need to consider some guidelines related to color, especially if the user are elderly, because it may affect movement and performance, tasks completions, and emotions. So I know this is short presentations, but it's for developers and designers, and one day maybe you will assess some applications to choose them, and it may help you how to choose these applications. Thank you for your attention.
Thank you very much. We will move to Cecilia Siklanai. She's a professor in the University of Pannonia. She will be speaking about route control and route planner for elderly wheelchair users.
May I get my presentation? Yeah, okay, thank you very much. Dear Charlie, thank you very much for the introduction. Ladies and gentlemen, my background is mathematician and software engineer, and my favorite topic is virtual reality, serious games, and assistive technology. Today, I show you one of my students' work, a new application for wheelchair users. His name is Gergő Andó. And we got the idea from that application from Sándor Navratil and Zsolt Mesterházy, who are member of Association of Wheelchair Users in Veszprém, our hometown, and Balatonfüred in Hungary. Over there, you see a lot of problems for wheelchair users. We cannot imagine that really if we never ever used it. As you see the problem, after then I show you our goal, motivation. Of course, there are other route planning apps. I show you some of them. And after then the new rolling up application, some words about the testing, and finally I conclude my presentation. So the motivation was the Association of Wheelchair Users in Veszprém and Balatonfüred asked us to develop an easy-to-use application and with their idea. Therefore, the Rolling Up project was born. We used participatory design, so the goal was to design and develop a route planning software for wheelchair users navigation that even elderly people can easily use. Yes, I know we have a lot of applications. I show you on the right side two Hungarian developed application. The route for you, it's really excellent, but has a big disadvantage. It does not show accessible toilets, restaurants, hotels, or even disabled parking places. The other one, the access for you, its disadvantage is that it doesn't have a route plan function. Therefore, the functionalities and advantages of these two applications are combined in the rolling up software to make it more convenient for the wheelchair users. Here you see the used technologies. It is developed both for Android and iOS smart devices. The programming languages, Flutter Map, and the database based on Firebase. On the left side, picture, it's not the final version because later we voted it that it will be not roll up but rolling up. it has two modes, register for registered users and login as a guest. On the left side, it's a usual registration process. You can give your email, password, once again password, after that register, and after then you can log in. The second picture is if you use it by a guest. Of course, you can give your email password. You can log in if you want, and if you can register if you want, and you can continue by a guest. But the difference between the registered user and the login as a guest user, as you use it as a guest user, you cannot send feedback about the map, routes, hotels, and so on. Right side, you can see the map, you can load the data, show your location, and you can plan a route by an optimization process. And there are two searching functions, the search by name, for example, by a street, a hotel, a tourist attraction, and so on. And there is a quick search type by icons if you would like to find a toilet for wheelchair users or parking places, hotels, restaurants, and many other facilities. And the right side, you can see there is three types of coloration of the map. The green means that it's easy to use by a wheelchair. The second is yellow means that, okay, you can use it, but you need some helper because Veszprém and Balatonfüred is a bit hilly and there are some dangerous routes. And the red means that it is impossible used by wheelchair users. Scientific feedback options you can see on the left side. You can write the name of the city, the name of the street, and the number of a house. And after that, like a short message, you can write what you have discovered. For example, change in road conditions, or you have developed you have found a new car parks, toilets, hotels, and restaurants. And on the right side, how can I begin the video to run? Yeah, okay, you can see my video. This is a Balatonfüred map. Anyway, last summer, Veszprém and Balatonfüred region was the cultural capital city of Europe. And you can see that you can find some places. And if you, over there, you can see that there are red, yellow, green routes, and you can quick search for a toilet or a cafeteria, and you can see every facilities in that territory. You can find conditorei, restaurants, everything. Here is your location, and from your location you can plan a route. Here you can find by the name a street, and later the video shows the sending message options or backward, as I showed you previously. Many thanks to the members of the Herend and Balatonfüred and Wheelchair Associations, not only for their idea, but for providing the map data, because they really worked that territory by wheelchair, every state, and it was our input information for the map, for their feedback, so using the testing, for testing and having the finished application tested. Here you can see some photos about the testing process. We have get a real useful feedback about that. For the testing, we used the system usability scale. It was a pilot study because it tested only 12 people, but later we would like to make a larger testing process, enough number for a real statistic analysis. Unfortunately, only 4 people were above 60 years. The system usability's average score was 75.5. It means based on evaluation that it's a good application. The YAS score, funny to say that YAS score, who were below 60, their point was a bit above 80. It means based on evaluation of a system usability scale that it's an excellent application. The elderly score was 61. It's okay, but maybe we can make it a better way. But I think the problem was not only because it's not easy to use, the problem was that those 4 people have not enough digital skills. To sum it up, it's a good application, user-friendly, and the suggestion is to build in some user guide at the first beginners and some information gradient of the roads. As I mentioned, that this place is a bit hilly. So the conclusion, I think our aim was successful to design and develop a route planning software for wheelchair users navigation that even elderly people can easily use. We tested it as a pilot study. Our future plan to develop or adapt it for different languages. As you see, it's really easy to change some words. For other cities and other disabilities, for example, for low vision people and so on. Nihil de nobis in nobis, it's a Latin proverb. It means in English nothing about us without us. The term in its English came into use in disability activism during the 1990s by James Charlton. And as I mentioned previously, we used participatory design. It means that from the first step, not only the idea came from wheelchair users, but during the developing process, every time we tested it. And if you allow me, I would like to use another meaning of the nihil de nobis sin nobis in the name of not only elderly people, not only wheelchair users, but for every disability, nothing for us without us. So the takeaway message is nothing for us without us. Thank you very much for the work of my students and your kind attention.
Thank you very much. And we will continue with Martina Steinbock. She's a research associate from Schoen Clinic Bed Ebeling. And she will be speaking about digital solutions, application for post-stroke spasticity, and sleep analysis in mild dementia.
Yes, thank you very much. I try to be very quick in 10 minutes, and also it's already late. So, yes, I am starting directly because we heard so much about amazing apps. It's very inspiring to see all this development that is coming here, and we also know that the digital health technologies have revolutionized the patient care and really offered a tailored patient health care, which is in the last years really showing a high potential that can facilitate the prolonged period of independent living, especially at home, and is also reducing the heavy care of the caregivers, as we saw before, right? So today I will focus on a wide common neurological patients. I'm working in one of the biggest rehabilitation centers in Bavaria, and we worked in huge Horizon 2020 projects. And as we also heard before, we always focus on developing an app, but then when the project is gone, nothing happens. So I want to introduce today 3 apps that we actually still use in our clinic and maybe inspires you to use it also for you. So first I start with the topic that we had also today, Alzheimer's disease. So we have over 10 million individuals that are aged 65 or above with Alzheimer's disease or dementia. And this really enlightens the urgent need of effective support. So despite the potential benefits, unfortunately, the adoption of mobile health technology is very rare and is very difficult. So we also know that we have studies say that there's a link between the cognitive decline and sleep apnea. So we often have patients in our Alzheimer therapy center that says, yes, I don't know, I sleep good, but I don't know, maybe I don't sleep good at all. So we developed an app that I will show you later. The second cohort I want to show you is a post-stroke, our patients after stroke. So 40% of our patients develop a post-stroke spasticity, and 20 of those even experience a significant disability from the stroke. And now the microphone is working well, I guess, yes. So also we have different identification problems of this post-stroke syndrome, and the app that we developed is really helping for supervising this. And also patients with dystonia. So we have this group of neurological patients, stroke and dystonia, and for both of them we developed a nice help during their stay in the hospital. So I will start now with the Alzheimer patients. So we have our patients 3 weeks in our clinic. They are coming with their caregivers, and we use this sleep labs. I don't know if you have ever been in sleep lab. It's a room which is absolute full of blinking and alarming devices, and it's absolutely not normal to sleep there. So it's very problematic to really find out how you sleep. So we have this medical CE certificated device. It's from Wittings, and it comes with an app, and it's actually ambient under the mattress sensor. So it is put under the mattress, and it gives information about the sleep quality, about snoring, the heart rate, and it also develops a sleeping index. And the sleeping index is sleep duration, sleep depth, and also the mid-time interruptions that are coming. So this really helped us to get an overview of our patients, and they had this for 3 weeks, so we really could see a good sleep quality. Okay, and for the next, we have a multi-professional team. That means this is a patient with stroke in our clinic. Usually they are always surrounded by doctors, by physiotherapists, and everybody wants to put something on the patient, and the patient is so in the middle of this whole multi-professional team. But what is actually important is the patient, whatever that was, good. So we have to put the patient into the middle from the middle of the circle outside to be one part of it. So we have to give back some responsibility from the patient itself. And therefore we created one app, it's a spastic app, and one app is called Dystonia app for stroke and dystonia patient. And both apps were created from health professionals and are also still supervised. So let me just introduce you to the first app. This is very, very simple. We have the two, if there are some neurological specialists here, but we know for spastic we have two evidences. One is the stretching and one is the active movement of the antagonist. So this is the simple as that exercise that we present in this app, and the aim is just to counterbalance the co-contractions that are developed for spastic, and also to give the patient a possibility to train for himself and get out of this multi-professional team responsibility. So here you can see just some advice. Here you have a test, it's called the spasticity test. This is a video that will ask, okay, if you try to rise up your arm, do you feel some spastic? Is there some tension? Then you have this green for nothing, yellow and red, and then it will suggest you some exercises that are very simple and very short descripted. And then we have the Dystonia app. It is not only used for patients but also for physiotherapists, because it can give them some education and insights of a therapy. It's a very rare disease, dystonia. It is one kind of a spastic. Some people have like a torticollis, it's called, when the tension of the neck is, for instance, too high and they cannot come. Usually botulinum toxin is injected, but this is not a therapy. So this is giving an insight of some exercises. Okay, and now I am rushing through it because I'm afraid of these 10 minutes. So for this sleep analyzer that we had, we know that we wanted to see the sleep apnea and the sleep quality, and we tested it on 69 patients with Alzheimer's disease, 21 were female. And the mean age was 72, so we had really older Alzheimer patients that we tested, and they used it for 8.2 days, plus minus. And in overall, we could see that the sleep efficiency is quite good. It's a very good quality of sleep, but we also see that that the apnea was quite high, which shows us, okay, this is a new maybe way of diagnostic sleep disorders for patients with Alzheimer's, and they could put this device back to their home, and so we could reconsider the whole diagnosis of sleep in Alzheimer patients with this app. Okay, I will continue. So for the Spastic app, it's very interesting because on the 25th of June, we are launching a new device with the exercises, but we just did a very mini study with just 8 users, and we are very happy that these 8 users are very happy with the device, and with the app, and with the videos and questions that are asked. So we have already plus 20 users per month, and we have 400 users since February, and yeah, it's rising, and maybe they did this spasticity test. Okay, 2 minutes, wow, good. Okay, that I said already, then I can say thank you very much. And before I say it's really interesting, and I'm very inspired from all the talks that we had today and also yesterday. I go out of this very, very inspired, and I really hope that the transition from just producing an app and then actually using it and bringing it to the patient, to the older person, this is really a very difficult part, and that's why we are already using those apps while the patients are in our hospital. So once they are getting out to their home, they're not alone at home at Bois, so they're not overwhelmed too much from the situation. And that's why we try to develop these apps and integrate them already in their daily life. And I hope that this is also a way that we can maybe discuss next year, Martin, how we can actually do it to really bring the user to the amazing apps that everyone here developed. Thank you very much.
Thank you. And I want to invite our last speaker, Muhammad Hanats Hanafi Ihsan. He is a PhD student from the Department of Electrical Engineering and Information System, Faculty of Information Technology in the University of Pannonia. And he will be speaking about multi-browsers development in virtual environments to enhance working experience older adults.
Okay. Good afternoon, ladies and gentlemen. Thank you for the opportunity in this occasion. I will present about my work related to multi-browser development in virtual environment to enhance working experience for older adults. Okay, as we know, current development of virtual environment or virtual reality currently is not only for gaming, but at the moment it is evolving for skill development environment or working spaces. And since the computer interaction, it is evolving since DOS from textual and then evolving into two-dimensional as Windows, and currently it is also evolving in three-dimensional interaction. Also, at the moment, for almost every desktop application is evolving into internet or browser-based application, such as document working, spreadsheet, image editing. Almost every application is migrating into browser environment. But in this case, most of us usually have many browsers at one moment. And sometimes it is confusing and overwhelming. We need to find which browser that we currently at work and which browser that, which types that we are looking. And I have initiative to create this virtual environment that have immersive experience. And then the design features that we create, it allows us to view multiple browser at the same times. And the type of this application that I created is as desktop virtual reality that can be run in Windows operating system. This virtual environment doesn't require head-mounted display and another controller. It can be controlled by standard computer peripherals such as computer mouse only, and keyboard. Okay, this is the virtual environment that I have developed. Sorry. How to play the videos? This is the videos. I don't know. This is a video. This is the virtual environment. Okay, this is one of the several tabs. Okay, this is spreadsheet. Okay, actually in this virtual environment, we have two types of interaction, 2-dimension and 3-dimension. In 3-dimension environment, we can explore the whole environment. But in 2-dimensional mode, we can only focus in one browser only. And then for the testing, we have several tasks to older adult to test this system. The task is finding today's news in Google or something, and then booking public transportation ticket and navigating around the virtual environment. And then the total participant that I get is 11. Their average age is 64, minimum 60, and I got 174 participant. And then most of them male, 7 male and 4 female. And only one participant that have ever tried a virtual environment. And then I also measure by system usability skill, and the overall score is good. But if I break down the data based on sex, it's good. But I also break down based on their last educational degree. Okay, for older adults that only finish high school, they judge our virtual environment is okay, the score is 69, but the older adults that finished their university degree, they give the average score of system usability skill is good. And then by age group, for 60 until 64 years old, they give a good score by SUS, and the participant that more than or equal with 65, they give us okay score in 67.9 and 1. Okay, and this research and this testing scenario is still running by now. But I can give a short summary. This multi-browser virtual environment show positive result based on our SUS score. And then for future development, we want to create enhancement on in interaction and usability, because with computer mouse we can with a computer mouse that have only limited button, we can design a lot of combination of navigation system based on that limitation. So to increasing the usability and acceptability in that virtual environment, we have planned to enhance our interaction and usability. And then for our future work also, we want to encourage more participant, more variative testing scenario, and also adoption and feedback from to refine and improvement the virtual environment. Okay, thank you for the kind of attention.